No, it doesn't want to work. Okay. Maybe you would like to go first while I figure out my technical problems. I'll check again. Everything has been really smooth this week in Barcelona, except for this moment right now. We'll just restart everything. What's the worst that could happen? No, this is totally me. I'm not even connected to the router. All right, that looks good. Let's make sure. Why are you unplugged? You're clearly plugged. I shouldn't have walked away when it was working. Sure you don't want to go first? I can continue to struggle here for a while. Sorry, I'll try to figure out this network thing for a third time.
Thank you. So why not? I'm going to be the voice behind the screen. Okay, also for the other side of the Atlantic, Jaime Lobato Cardoso. Now it's working?
See?
Okay, this is live coding networks. I mean, if it's working,
Don't worry, don't worry.
If it's working, just go and
See, if it's working, better start playing. No?
No?
Are you
Okay.
sure? See? Okay, well.
Okay, then just maybe you can present yourself, Jaime, and if I need to intervene, I let you know.
When can I have signal from video from the computer, please? Sí, bueno. I don't know why it's blurry. It's not supposed to. And No, it's a projector. See. So, well, huh? No, don't worry, don't worry. It was a projector. Focus. So, well, thank you very much, Ivan. It's very nice to see you again here in Angar after so many years of peace. I hope I can be here with you for the closure of Top Lab Barcelona from the for your project. And thank you. Well, I'm Jaime Lobato. I work a lot with Super Collider. Well, and another programming languages as well. For live coding, I mainly use the Super Collider and Hydra. But also I work a lot with biosignals, and I want to talk to you about what I'm doing. I have been working a lot with some unconventional computers paradigms, especially with the genetic chips, like models of logic gates that doesn't work with electricity, but that works with like communities of bacteria communicating themselves with quorum sensing, or with chemical oscillators, such as Belousov-Jabotinsky reaction. And now I am working with this project of neurocomputing. As I told you, I work a lot with biosignals. I'm like developing my own amplifiers of biosignals in this project, Mind Coding, that you can see some images. The idea is to develop develop a platform that can help you to write code. Generally, all the projects that use electroencephalogram information, they just took they just took the data and use it as a data flow, a data stream, to connect them to some synthesizers or like video controls. But in this project, I am trying to develop this platform so you can make, you can write codes with this electroencephalogram sensor. So the idea for this project, I am using this commercial MindWave electroencephalography platform. I'm just about to make using one electroencephalogram. We are like working in Independencia Biolab. That is a biohacking laboratory that I run in Mexico City. But for the moment, this version is working with this MindWave sensor. It only has one sensor in the frontal lobe, and then I use the information to generate a couple of indexes. One is like attention, attention index, and the other is meditation index, like active or passive attention. So the the platform is inspired of this platform that Stephen Hawking used to have to write code, because in the beginning he was like choosing letter by letter, but then the platform started with some machine learning tools. The engineers that work with him in this platform started to guess from the first two letters. They can offer some possibilities, and then in the last stages, almost the algorithm knew him very well. So even the algorithm can like guess what he's going to what he's going to say. No, with these machine learning algorithms, the platform, yeah, had this all this vocabulary that Stephen Hawking used a lot. And then as well, I started to work with this Emacs IDE platform for writing code. And this has this snippet feature that as well you write 2 letters and then the IDE offers you possibilities to write faster. So basically, is what this this platform do. No, I have found as well that this, for example, for making from scratch, manipulate some neurons individually to trigger some behaves. So, bueno, in this at this moment, I am trying to use some machine learning algorithms to analyze what is the behavior of the cluster of neurons, because each neuron has their own timbre, their own waveform. So it's like trying to take apart the information. For example, in an orchestra, trying to take from a whole recording the information of the flute or the violoncello or whatever. That is not that easy, even with the neural networks or with the more sophisticated. Well, neural networks doesn't work very well for that. It's just like principal components, as and well, I'm trying to link the individual behavior of each neuron, so I can then make some manipulation of each one to generate patterns. As well, one of the things I have found in this research is that well, this comparison of our brain with computers have reached some like dead ends, because the computer we use has this von Neumann or Princeton architecture, and no matter if you even if you have the most sophisticated machine learning algorithms, you cannot change the architecture of your tool, and that like makes some like possibilities and not possibilities of doing things like in a more mathematical way. No, that's why, for example, the computers that have this like video card works better to compute image, because those are like designed for make calculations in linear algebra. So it's already a matrix calculation. So that's why those work so much better for making image and not the other process. No, so both biological neural networks can change their architecture like in real time dynamically, particularly with the secretion, the emission of serotonin and with magnesium. So that's why the digamos the computational theory we have cannot achieve this complexity the brain can offer to us. No, and well, I would like to talk with you about these ideas about biological computing. I don't know, maybe we can open the mic, or I make the performance first? Ivan, what do you think? Wanna play? Are you working?
I'm working. Let me
See?
Brian is ready. Yeah.
Okay. And then I can make some more electronic digital live coding for you, because I don't have my neurons with me now, only with my brain. Okay. Vale.
Mr. Canada, 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 Mr. 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 You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all me like a kid. Me like a miss. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You miss me like a kid. Me like miss you. You always treat you all you all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. Mister me like a kid. Me like a mister you miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You always treat you all you all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. Mister me like a kid. Me like a mister You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You miss me like a kid. Me like miss you. You all miss me like a kid. Me like miss you. You always treat you all you all miss me like miss you. You 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 miss me like miss you. No, be like a no. You miss me like miss you. 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 You all be like a mister be like a you miss me like miss you mister be like a you miss me like you miss me like you miss me like you miss me like miss you you all you miss me like you miss me like you miss me like you miss me like miss you mister be like a you miss me like you miss me like you miss me like you miss me like miss you you all you miss me like you miss me like you miss me like you miss me like miss you mister be like a you miss me like you miss me like you miss me like you all miss Mr. Canada. Kane, you all. Kane, you all. You all. Mr. Kane, be like a kid. Mr. Kane, be like a kid. No, be like a kid. You always. Mr. Kane, be like a kid. Be like a kid. Mr. Kane, miss. You always. And Mr. Kaneda, you punk, Mr. You always. And Mr. You miss me like you miss me like you miss me like be like miss you Mr. Be like a you miss me like you miss me like you miss me like you miss me like be like miss you and you all you miss me like you miss me like you miss me like Mr. Be like a be like a Mr. Be like a Mr. Be like a Mr. Be like a no be like a Kaneda. You always treat Mr. Kaneda be like a kid. Kaneda. You always treat Mr. Kaneda be like a kid. You always Mr. Kaneda be like a kid. Kaneda. You always treat Mr. Kaneda be like a kid. Miss me like miss me like you miss me like you miss me like be like miss you Mr. Be like a kid. You miss me like you miss me like miss me like be like miss you all miss me like miss me like you miss me like you miss me like be like miss you Mr. Be like a kid. You miss me like you miss me like you miss me like Kaneda. Kaneda. That's Mr. Kaneda. You Kaneda. That's Kaneda. That's no Kaneda. Kaneda. That's Kaneda. That's Mr. Kaneda. You punk. Kaneda. That's Kaneda. That's no Kaneda. Kaneda. That's Kaneda. That's Mr. Kaneda. You punk. Kaneda. That's Kaneda. That's no Kaneda. That's Mr. Kaneda. You punk. Mr. Be like a kid. Missy like you. Missy like Missy like Kaneda. That's Missy like you. Missy like be like this. You Mr. Be like a kid. You Missy like you. Missy like you. Missy like you. Missy like be like miss. You you Kaneda. That's Mr. Kaneda. You punk.
You always treat
Mr. Kaneda.
Be like a kid. Be like a kid. Mr.
Miss.
you always treat Kaneda.
Mr. Kaneda. You
Be like a kid.
You always treat
Mr. Kaneda.
Be like a kid.
You always treat
Mr. Kaneda.
Be like a kid.
you always
Mr. Kaneda.
Be like a kid.
you always treat
Mr. Kaneda.
Be like a kid. Be like a kid.
you always treat Kaneda. You always treat You always treat
You've always been a
Kaneda. treat. You've always.
Mister, you miss me like, you miss me like, you miss me like, me like miss, you miss me like it. That's Mr. Kaneda, you punk! Miss me like Kaneda! That's Mr. Kaneda, you punk! Mr. Me like a no, Kaneda! That's Mr. Kaneda, you punk! Mr. Me like a Mr. You Kaneda! That's Mr. Kaneda, you punk! You always Mr. Kaneda.
Are you in? Are you playing? What's wrong? What's up? What is you?
What you?
We're here.
Open.
Shut it.
Shut
I figure now. Open. Shut this good. You would think what you want.
Yo soy el Macalacachín.
Maybe
Sí.
meow, meow. That one. Yeah, yeah.
Sí,
Now it's
sí.
working.
Hola.
So
Sí.
maybe if we can have a short Q&A part. We had some questions in the chat, and also maybe here there are some ideas, opinion. Hope you haven't drunk.
He didn't talk about his
Also,
well.
yeah, you said nothing.
It's fine. Doesn't matter.
Just or anything.
Yeah,
Give you the other mic, Jaime.
I don't know. It doesn't matter. Whatever's fine. I'm good.
Okay, maybe I should pass the other one over there.
That was awesome. Thank you. Jaime, my question for you is about the mind wave. You were talking about the mind wave EEG instrument that you're using, and I'm really curious why you chose that one, because I mean, I'm working with some similar technology, and I found OpenBCI to be really nice in the sense that you have more than one sensor and open framework and all kind of things. So why did you choose MindWave?
Because it has only one sensor, and the idea, I mean, even because there is no still good maths or mathematical framework to know what is happening with the brain, even if we can see the brain waves. So I didn't want to have more complexity on that and like focus in the problem, in the question of making like a mind, like a thinking architecture in an analogous way to software architecture. So there is a lot of debate of what we can do on or what we can know with information we take out from the EEG. So this is like for a PhD research, so I didn't want to like focus on that for the moment.
Um, I have a question, but I think that I got lost a little bit in the talk. How do you? I don't understand how you actually measure the neurons, the cluster neurons in the leech. Like, do you hook the leech in the cluster, and then you take there's like a microchip that translate it, or how was that?
No, I took a microdiode, and then one of the terminals of the cluster, I connected directly to a wire, and this wire has another termination in an amplifier, and then we can amplify the brain waves and the waves, and see the information.
Well, the cluster waves, no?
See the cluster, yes. Mm-hmm.
And a follow-up really quick. So are you trying to separate these waves? Like to see, because you saw that you told us that there's like a lot of waves there. Do you think that they have like periodicity, like that you can see that they repeat themselves in cycles?
See, yes. More than cycles, waveforms.
Yeah, like they do, like,
See,
and then but you can do like an analysis of separating these waveforms
see, yes.
because of their periodicity, no? Like
See,
you can
yes,
do like
I'm working with the FFT and then with principal components algorithm, so I can have like this like timbrical like signature of each one.
I would suggest to use Fourier analysis, like to see if you can actually see the frequency of each or the periodicity of
See,
each
yes,
one.
yes, yes. Fast Fourier transformation.
Yeah. That's what you said.
This is FFT.
I'm sorry,
See.
I don't know the acronym.
See, with Fourier, and then with the,
With the principal components.
with the principal components, I can like kind of.
You need a lot
consider.
of samples, no? like a
See,
lot of
yes,
information.
yes.
Thank you. That was very interesting.
Thanks.
Yeah, sorry, I want to go back to the question before, and I know you're going to find me a pain in the ass, but
No, not at all.
one sensor, and you said it's in the frontal lobe, but you're measuring attention and meditation. But we know already, and this is not PhD level, this is common
See, yes,
Google
yes.
knowledge, right? That
Alpha waves are better measured in the back. Yes, I
Yeah,
know.
so that meditation signal that you're looking for, it could be on the opposite side of the brain and really difficult to read on the frontal.
Well,
so-
the noise reduction I made works pretty fine. I mean, you can actually
Yeah.
realize that you are controlling these two indexes.
Okay.
So
well,
for the moment it works. But yes, I am going. I am like making like a version of an EEG with myself, and I'm going to start to plug it in different places. Yes. So I can like link more cognition abilities to the software. But I wanted to start just with the front lobe,
I
so
did
I
the
can
same thing.
reduce. So I can
actually-
reduce the complexity and start to make the front end part of the software. No.
I agree with your approach to start with one sensor, but in a way, then you can reduce the complexity further, I think, by isolating the different parts of the brain so that you have less noise overall. Like a different sensor here versus here, the comparison cuts out a whole lot of noise. And
Yes, but it has not so much noise. This sensor, like the electricity. I mean, it has like a reference electric part that you connect in your body. So for noise reduction, it works like fine for the moment. I know it's almost like a toy, but I mean, the idea was starting to develop the more this philosophical question about like what could mean that the brain like fails in something. No, I don't know if it's possible. I don't know if epilepsy is like a failure, or I don't know. Maybe I wanted to go
Well-
deeper in these questions for the moment.
I know after when we go to the bar, we're going to sit next to each other and debate this all night long.
See, yes, for sure.
And I will show you my EEG if you show me yours.
Yes, yes.
Yes. Sorry.
Thank you. It's super interesting what you do. I have 2 questions.
Mm-hmm.
Hope it's not too greedy. The first one is about I'm not sure that I understood this, but you're using AI in your processes,
See, so yes, some machine learning algorithms, yes.
and what are they trained on exactly?
They are trained. The first one in these mind coding algorithms. These are trained to know me better, so they can offer me faster options to choose to go into the map of the architectural synthesis design, and mainly is like the algorithm can know me better.
Okay, so it's
So
training on you.
Sorry?
It's trained on you?
For the moment, yes, because yes, for the moment, yes, it's
Okay.
trained. It's just trained on me. I show this as a installation, so the weights on this one step, this ¿cómo se llama? This one step of first level transition matrix changes, but then I use it back, and it's back more like into the way I use the interface. And in the other part is just to analyze the timbre of each neuron in this.
Yeah, that's the one I was interested in.
Mm-hmm.
And that one, you're training it only on itself, or are you taking multiple leech bodies?
Multiple as well. I can connect several terminations, at least 7 for each little like cluster, and also I can make some. I can manipulate the cells electronically or chemically, and then I start to see some patterns depending on what I do with the cluster. So
I saw that part. I just wanted to clarify about how you were using AI. I have no further questions on that. My next piece. Oh my god. My next question is. My mom says peace all the time. It's really embarrassing. But like when. I see that you're working in bio art, and I guess maybe to a certain degree, I'm not sure if you're like aware. I'm not saying this is a diss at all, but like if you're aware of biofeedback art, I'm only saying this because I just don't want to make any assumptions. But I'm just curious if there's like any artists that you feel like if there was like a lineage of thought that you're following in, like who the most important is.
like an inspiration for me. In this,
or like who if you were in an exhibition, who would you be really happy to exhibit with?
well, I think would be like it's not that I'm like fan of a lot of artists in technology, but with that question I would like to show beside, for example, Sildo Meireles, this conceptual Brazilian artist, or Gordon Mata Clark. But for sure, Sterlak is a very huge inspiration on my work, no, for sure. And also all the team in the, I always forgot this research team in Australia that very famous in bioart. They also have worked with neurons and with something called MEA. Symbiotic, exactly.
So
Symbiotic is also for me like huge. Marta de Menezes, more in the molecular biology realm. I really like her work. Yes.
I just find it super interesting because your answer was like not anyone in biofeedback music history, but mostly in art history. And so I take notice, and I'm like, cool. Okay.
Well, there's also this composer, American composer, el que hace Echolocation.
Lucier.
Alvin Lucier.
Yeah, he seems like he's the one that
I actually
everyone's
went to study a little bit when summer with him several years ago, and it's like yes, because I have been working as well with the human echolocation for several years, and this guy was like a guru. So as well, he had this music for solo performer that was one of the first pieces using biofeedback with the alpha brain waves in the 58, I guess. So see, Alvin Lucier as well is like one of my top.
Thank you.
What do you?
Sorry. I have a question for Shawn.
Yes.
Could you explain a bit your setup? I think Ryan was playing from New York. Was he playing tidal cycles in your computer?
Yes. So a little bit. I can show you one picture that might explain everything quickly. You wanna, I can, maybe. This might be too much already. All right, hopefully this will be significantly smoother than an hour ago. Something like this might make everything more clear. This is kind of what's happening a little bit. I'm using the Atom editor, which unfortunately, if you haven't noticed, is going to be deprecated by GitHub because Microsoft bought them and then they're squishing it and whatever. But anyway, so I'm using the Atom editor, and then I have my own package for Atom, which allows me to program in multiple programming languages simultaneously in the same text buffer. And then depending on which portion is edited, they get sent to different things. So the top part is Python, which is sort of a regular execute sort of shift command or shift enter or command enter message that goes to Touch Designer. The OpenGL section automatically gets sent to Touch Designer after 200 millisecond key press. And then Ryan is editing title cycles, and then when he executes, it executes on my computer. So if you imagine that this little while, and so in title cycles goes to Super Collider goes to the speaker, and then I also pipe the audio over into Touch Designer. So everything ends up in Touch Designer on the other computer. And then I've rebuilt the forest from the web, which Yvonne mentioned, inside of Touch Designer, and then I can also run machine learning like StyleGAN 2 or StyleGAN 3, and then that goes to the display. But if you pretend like this is my little setup, then out here, Adam is talking to this Firebase Google backend, and Ryan is also talking to Firebase Google backend out in the cloud somewhere. And if we wanted to, then Yvonne could also connect in to the Firebase Google backend. And then what's also happening is that this computer is seeing that backend and then using that in a Chromium instance for the code overlay so that you can actually see the code on top of everything else that's happening. Hopefully that was clear.
So if I can cut in right there, answer your question. Excuse me. So I've seen you play on Monday, and I've seen you play today, and I've read your paper from the last ICLC, where you talk a lot about, yes, we know everything about you, where you talk about machine learning, and not just SIBO, but also your graphical work in machine learning that uses machine learning. And so one thing we have discussed a lot in the scene over here on this side of the Atlantic in the last couple of months was the whole idea around transparency in code, and obscurantism is dangerous, show us your screens, which kind of extends to show us your thoughts. And from your code today and from your code last Monday, I couldn't see that you were using any kind of machine learning methods and machine learning, methods, and I already said that. But, well, on Monday maybe a little bit, because the images that you used were kind of giving it away. Yep. Exactly. They looked very much like GAN images. But so, what's your stance on that? Do you think that's a problem, or do you think like it doesn't matter, or what's your idea about that?
You mean in terms of using machine learning at all, or just in terms of?
No, like the visibility. Like it's hard to tell that you are using machine learning, and like a lot of thoughts around live coding revolve around the idea that you show people what you're doing by showing them your screen. So
Yeah, it's a bear to use. It's really hard to get machine learning to do anything.
Well, that's for granted, yes.
That's part one. I mean, the best. I mean, I'm still working on trying to do this. Being able to manipulate the machine learning on the fly is quite hard. And so the best I've been able to do is what I have up here at the moment, using Stelagan 2 or Stelagan 3, and using some pre-trained open source CC BY 0.0, so it's completely open, like MIT license, pre-trained neural nets, or training my own neural nets with my own content from. If there are people who have signed off on things saying it's okay to use my likeness in your machine learning thing, so trying to be as transparent about the capturing of the data that I'm using and letting people know what the data is that's being used, because the data curation in machine learning is a huge, huge problem that has been talked about through Isaiah and through Sonar and whatever. As far as trying to live code and expose it, it's difficult to show a lot of what it is, because what the Stelagan is expecting is this little source thing over here, which is a 1 by 512 dimensional array of values -1 to 1. And so the easiest way I've found to be able to drive that is with a Perlin noise single column image, and then manipulate moving through that space or pushing through Perlin noise space and letting it generate that -1 to 1 value, and then shoving that down into the bottom down here into this little, can't find the projector, this part here, which pulls on the graphics card itself. It's pulling that image out of CUDA space and wrapping it on a Python tensor, and that tensor gets shoved into a neural net that's loaded, plus a bunch of other stuff to make it go, and then it processes it and then dumps out a tensor, which then is unwrapped back into a CUDA image, which then I can get back onto the screen at a reasonably 20 to 30 frames a second on a RTX 3090, which is not too bad at a 512 size. A lot of the, it's not as obvious in the performance on Monday at Isaiah. It would, I mean, it depends on the audience, how much familiarity they have. I mean, Stelagan 3 has about 130 different layer stacks. And so I was manipulating about 5. And so what I generally do is load 2 copies. One is meant as a constant, so I don't destroy it, because it's very delicate to modify the weights of a tensor layer. And if you push them too far, they end up totally breaking, and so I have to have a reference point that I'm always using before pushing it back into the output source. And so generally what I was using was the noise layers at different granularities, so 4 or 8 or 16 in powers of 2, which would represent sort of 4 pixels, 8 pixels, because of the way the Stelagan layer stacks go down and then come back out again through the UNet. And so I can manipulate those individual layers and then cause them to look more or less noisy or have them inverted in particular ways. So I can manipulate those, but making that more obvious as to what I'm doing is a very good question that I have not been able to get to quite yet, but that is a good point to make and try to figure out.
Okay.
Sorry, that was a really long answer to get to your very simple question of why I wasn't showing anything.
So I don't think it's a simple question, obviously, but if you boil it down, it's really not so much like how do you do it behind the scenes, but do you think it's problematic in a live coding context that you cannot show that?
Yes, I'm working on another project which is due very soon, sooner than I would like it to be, where I'm trying to work with Stelagan, and there's a field of AI that's called XAI. It's explainable AI. It's why it starts with X instead of E, I don't know, but XAI is explainable AI. So trying to, in that, it's going to be not live coding, but it will be a static sort of animation length project where it's trying to expose the layers of the Stelagan and then be able to swap them around and try to figure out how to visually demonstrate what's happening behind the scenes in the neural net so it's more exposed. I think there's, maybe not directly said, but there's a lot of faith put into neural nets that to me feels like it's a little bit too much hands-off and allowing the machine to sort of take over when it probably isn't going to be perfect all the time, and so we ought to know what's happening inside of the box rather than just assuming the box is great, the box will always work. But
yeah, well, I think that's what we get to in this question, right? Maybe the box isn't doing anything. You know, and I think that's what we want to see. Like, what exactly does it bring to the context that we're seeing? And
Yeah.
if we can't know, then we don't know how to value it in that system.
yeah, that's true.
So I love the idea that you can take pieces of it and visualize that in some way.
They're starting, some of these layers here, this is not my picture, this is directly from the GitHub page for StyleGAN 3, but some of these layers here on the left are in between layers leading up to the final output, which is on your right, extreme right. So you can kind of see what is, some of the individual layers are behind the scenes, but this is one selected layer out of many.
Sorry, but I think just Jaime is going to hate this, but rather than a question, it's a thought. But I would like to know your opinion about, like, for example, in live coding, we are showing some particular part of the process. And for example, Alex McLean decided to show the pattern machine instead of the synthesis machine. I mean, there are some things in tidal cycles, but what we see in a tidal performance is like the pattern machine. So in AI, maybe using machine learning or AI or whatever, what we can visualize because of the huge infrastructure is going to be small pieces of that process, like maybe the live training, or maybe changing the parameters of the algorithm, or maybe so in this tension that we are living in a way, because we want to use this because they create really nice structure to experiment. And it's nice because otherwise we would be still writing small SynDefs, no, in Super Collider, like back in 2009. And this is like, I like them, but it's hard to create particular types of music with that. So it's seductive to use. I'm also guilty of using some machine learning in my performances. But there is this tension, no? Again, these different ethos, no? The transparency, the algorithmic manipulating algorithms in real time versus these black boxes, or where the data come from. So what do you think in this, now that we are showing small pieces of, what would you think would be the most interesting part of the machine learning whole process to be visualized within a live coding?
I think, depending on the type of live coding, I think if it was musical live coding, I don't know how well to visualize. I mean, it would be numbers coming out. I think the visual live coding has an advantage of being visual images that are coming out, so it's a little bit, well, for me anyway, it's easier to see what is happening in the layers rather than sort of numbers if it was a musical or other type of machine learning. I mean, aesthetically, these are okay for a moment, but I'm not totally taken with the layers in between. So from an artistic standpoint, I'm not super crazy about it. I don't know that that tells me a whole lot, because this is the particular Flickr face high quality data set training that looks like this, that always looks like faces. It's always going to look like faces because it's only always trained on faces, so they're always going to kind of have this look to them. The toolset itself has a visualizer that you can run and sort of pick individual layers out and look at them and sort of manipulate them. I think training other things with it and pulling out layers, if they have an image net, I don't know if they have an image net yet for StyleGAN 3, and then trying to parse through that, which has a wider range of images that are pushed through it, to see if this is more interesting or has something else in it that's more revealing about its ability to sort of generate almost anything rather than only faces. This StyleGAN 3, I think historically, is kind of geared towards being able to have seamless faces. So part of the way the arcs and the latitudes and the longitudes run across the face are designed so that it can warp very smoothly from face to face to face. But if I want to do something else, face to car, to cat, to frying pan, I think it would look very different, and I think that would be more interesting to me. Pulling them out is tricky. It'd be great to just write a program that would just pull the whole sequence out at once and see how this looks. That might be something to do. I don't know if I'm really answering the question. There wasn't really a question, right? I didn't have to answer anything. I could just talk about stuff. That'd be fine.
I have a question for both of you. Taking your both projects and putting them together, do you think that, well, it seems from the outside that we are trying as human beings, trying to replicate a brain with BioArt and well, your neural experiments with inputting signals and everything, and then artificial intelligence, isn't that the brain? Putting a lot of neurons together with
I first want to say yes. I hate the Ivan's question. Nah, no es cierto. No. I mean this for me. It's an excuse to keep doing new things and experiment on them and learn about myself and about the tools I use. No, so but I have a good time after all. No. Just I know there's limitations and some things I don't like. For example, I really don't like to kill leeches to take the cells, for example. But there's a way I cannot do it anymore. Like you can convert cells, skin cells into neurons. You kind of denaturalize them, like with molecular biology, and then like force them to convert into neurons. For example, something I would like to learn. But this is it's more like a pretext to do fun stuff. See.
I was hoping you wouldn't pass it back. I think, I mean, all of this, I think what I would add to that, though, is that for me it's an element of critique, which is partially about trying to present what is in the neural nets in live coding, because as of now there's very little effort trying to show what is inside of the machine learning. So this is me trying to approach it from live coding and trying to start to pull it apart. It is step one. It's been 6 months, 9 months, baby steps. Like to pull it apart further. Of course, the more research I do into machine learning and what's happening inside of it and the data that goes in, the more it concerns me, so the more I feel like I need to critique it and try to expose it more. So I don't think this is the beginning for me. I think there's a long way to go. But I'm pushing more into it, I think, than where I'm at now.
Anyway, I think we really can learn a lot about our cognition and animal cognition while running this experiment. So yeah, I mean. It's more like a path, not like a goal. That's it.
Oh, okay, so this is kind of a follow-on to what you're just talking about, and the question of whether these explorations with neural nets, and either in a biological sense or in a digital sense, where does that lead us? But I can't help but come back to the sense that in some way what we're taking out of these black boxes is like maybe we select a certain noise generator. We can have all the noise generators we want in simple forms, so what is the neural net actually doing for us more? If the only thing we can understand from it is some kind of generative thing we don't understand, then I don't know. I suppose the critique, in a way, if you employ that in your creative endeavors, is that like here I'm showing you something that we don't understand. I'm including something to show you that we don't understand it. Shawn, I think you said you were selecting noise layers from these. So. When do you think we get to a point where we have something more than noise out of that?
didn't necessarily arbitrarily pick those. I picked those ones because they had a large effect on the output image that I could use quickly. Some of the other ones did not have as large of an effect on the output and weren't as aesthetic as the output on them. So that for me, experimenting with different layers, those ones worked the best for what I needed. I mean, the trained neural nets are very tricky because they're both. I see them both as databases and as functions. Some of the neural nets are as small as 50 megabytes or 250 or 300 megabytes, which is not, sounds big, but it's not that big. Often they're trained from terabytes of data, but all of that data is then compressed down to this neural net, which can regenerate anything from that massive data store, but yet it's also a function at the same time. You just have to know where it is. So it's like a compression of data and it's a function at the same time, and I think a lot of people, it took me a long time to sort of grapple with this idea that it's both things kind of at the same time, and then if you tweak something inside, you're changing the data and you're changing how the whole thing runs. Part of my experimenting with this is saying, hey, guess what? Scientists are making this stuff all the time, and they don't know how it works. We should be asking them, maybe you should figure out how this works so that we're not just like shoving it in a Tesla car or something, or shoving it into something else and assuming it's going to be cool. I don't think it's going to be cool.
Well, I love noise. So I don't want to go out from noise. Now, for example, I have this project, this piece, exactly with this style gun for faces. And I ask a lot of people in the public, whenever I put this installation, to close their eyes and model from their memory the face of a very beloved person with a 3D sensor, with a lip motion. And all of the 3D models I have, I took several pictures, and of this abstraction, and I feed these style guns. So I want to erase the memory of the neural network, and then I went for the packages of information where the weights of the neurons were, and I could see a change in this. Like the neural network was like, oh, what the fuck is this? This is not like a face. But the generator, the generative part of this style gun, still wanted to make some faces. It's very beautiful. I can show you later the video. But yes, no. I wanted to like make it to forget and stay in the background noise as of no, like it's just a poetic gesture of, like a biological neural network memory erasing the memory of like a digital neural network, no?
Yeah, well, basically it's just saying thank you, both of you,
Thank
for
you.
being here, and
Thanks for coming.
Thank you for the community, and that's it. Trobada 3.0.
Yes.
You closed it right, so I don't have to say anything.
Well, let's have a beer and we can keep talking. No? See? Thank you. Thanks for
everybody.
coming.